This is the work solution to unit test 8, question 5. This is the second part of the question, and I'm going to be looking at part D. In the first part, we were dealing with two connected particles, like so. Then what happens after 0.8 seconds and 0.9 meters, this sphere hits the floor. That means this string becomes loose. This has moved forward the same distance in the same time, but has not reached the pulley. We're asked to find the total distance from here to its final resting spot. So what I'm going to do is I'm going to draw A in its original position. Then it moves 0.9 meters, and that movement is caused by the gravitational force acting on B, which disappears once B hits the floor. I'm going to call this position A dash. This will then have some speed, and because of the resistive forces, this will start slowing down, and it will eventually come to rest at what I'm going to call A dash dash. To work out how far it goes before coming to rest, I need to know its original velocity, and I need to know the acceleration here. So the first thing I'm going to work out is the velocity at A dash, and I'm going to use SUVATs to do that. So S equals 0.9, U equals 0, V is unknown, acceleration we have worked out in the previous question, which is 45 over 16, and time is 0.8. I'm going to use V equals U plus AT just because this feels the easiest. So V equals 0 plus 45 over 16 times by 0.8, which is 2.25, and that's meters per second. So what I'm going to do is add this to my diagram, and so it's moving in that direction, 2.25. Just for a bit of common sense, we can see that this thing will start slowing down if nothing's pulling it. So it's going to slow down due to the resistive forces. So I'm just going to take this part of the diagram and I'm going to redraw it. So 0.8 kilograms. There is a force this way, which is friction. And we worked out in the previous question that the frictional force is 6.135. There are no other forces acting on this, so it must be causing it to accelerate or decelerate in that direction. So 6.135 is equal to 0.8a. Divided by 0.8, we get 7.66875. And although this is a very weird acceleration in terms of the number, I'm going to have to use that exact value because rounding errors will cause bigger and bigger problems. So, last but not least, let's try and work out x. So I've got my diagram looking something like this. I know it's travelling in this direction at 2.25, and I'm going to do my SUVATs again. But this time I'm doing from here to here, that's the idea. So S is x. I don't know that distance travelled. U is this speed here. It was V, but it was V when I went from here to here. From here to here, this number is now U. V is the speed at this point here, which is 0. The acceleration is minus 7.66875 because I'm taking this as my positive direction. And I don't need x, so I'm just going to put a cross here. So I need an equation that links SU, V and A. So V squared equals U squared plus 2AS. Again, I could substitute these numbers in here and try and get the solution. But what I'm going to do is I'm going to make S the subject. So V squared minus U squared over 2AS is equal to S. So minus U squared divided by 2a. Substituting into here, V squared will be 0, so it's minus 2.25 squared over 2 lots of minus 7.66875. That equals S. Typing this into a calculator, we get S is 0.33. And just through a little bit of logic, we can kind of think about 30 centimetres feels about right. If it's done 90 centimetres in the first section, it's probably going to do less than that when there's no forces acting on it at all. You need to be really careful here because the question asked for the total distance, so it wanted to know the distance from here all the way to here. So last but not least, we need to 0.9 plus 0.33, which gives me a final answer of 1.23 metres. That's the question complete.